Stephanie, I thought it'd be easiest to just record a quick video here. I've got all the information I need here. I'm going to show you how I got it. That way I'm not typing and talking at the same time. So the first thing that you want to do here is notice I've got all the data here. The square footage data and the price data of these houses. Let's see, the price data is the Y variable. The square footage price is the X variable. And so how I got this regression, the regression data that I'm going to get for you is everything that's right here, and I'll show you how I got it. Let's see. Let me just get through that first. So the data, let's see, go to data analysis and then go to regression and hit OK. And let me just do this from scratch here so you're clear on how I do this. So what you need to put in here first is the dependent variable. So that's going to be price. Screw that up here. Go back here. So you can get the non-numeric tag. So just click on that top value, hold down your mouse, and just drag it down. So it gives you B1 through B106, and then the X variable, same thing here. Just go get the X variable. And so you got A106. Let's see, we want labels. Yes, and I just have an output range of E3. Let me just show you, and this will just duplicate itself here. I don't think I need anything else, and so let's just hit OK. Is overwriting? It's okay to overwrite. Well, it took away some of my details. That's okay. I will do that. I will do that again. That's not a big deal. All right. So here's the regression results based on all this data. So I'm not sure that I saw that in your screenshot. But remember that now the regression equation, let's see what you're going to want out of this. Or let me just remind you, in the case where you have one independent variable, that equation will be written as a y hat equals b naught plus b1 x1, right? Where y hat is the estimated value based on some square footage input, which you've got right here. So the b naught is the intercept. Let me see, so I'll just put here b naught, and then b1 is this coefficient. B1 is the coefficient of size, and that's about $108.36. So just to write this equation down, what I did is I rounded the 5 to a 6 based on this 8. So B naught plus B1 X1 minus 15776 plus 108.36 times X1. So the first thing you need to do here is you need to get the estimate for a house that's 2,200 square feet. So you'll notice what I did here. Let me just kind of go through the mechanics again. So I'm just going to replicate this equation here with the values, the numerical values from here, and then I'll enter the 2,200. So it's equal to the intercept plus the coefficient times 2,200. And that's, let's see, $222,624 is the estimate based on the regression equation. Now, what it's asking you is what is the 95% confidence interval for a house that is 2,200 square feet? So remember when we talk about a 99% confidence interval, the Z critical values for 95%. I'm just going to write this. Remember, it's plus minus 1.96, but we'll just put the positive here. Now, notice here that the standard error for this distribution of sizes is 3.45. So if you think of that in terms of a sampling distribution, the standard error, sample standard deviation divided by the square root of the sample size is about $3.45. So what we're going to do here is we're going to come up with a 95% confidence interval for the average. So this would be the average price per square foot based on what we're seeing in the data. So let's see, let's say the lower value of the price here is going to be the mean, so equals the average. Let's see, the lower, so minus the standard error times the Z critical value. So the lower value or the lower price here, or the lower bound for a house with 95% confidence interval is about $101.60 a square foot. upper bound, same thing. We're just going to add the standard error times the Z critical. So the average plus, let's see, the standard error times the Z critical value. And so the range here for 95% confidence is going to be about 101 to 115. So then it's asking for a house that's 2,200 square feet, what is the 95% confidence interval? So again, we want a lower and we want an upper bound. And what we're going to do, we'll just go back. I think it's suitable to just go back to the regression equation. And what we're going to do is instead of using this price, 108.36, we'll use the upper and lower. And we'll see what we come up with. And then I'll show you how this kind of all goes together. So the lower, again, will be the intercept. Let's see, lower. So I'll subtract, let's see, the lower value of the 95% confidence interval times 2,200 square feet. That shouldn't come out to be that. Why is that negative? F19 plus I23. What did I, let's see, I23 times 2,200. Let's see, lower bound here. One more time. Equals, that shouldn't have been negative. That's my mistake, Stephanie. Hold on, let's see. This, I already have the lower bound here as it's $101. So the lower bound is going to be the intercept plus, sorry, I have an extra negative sign in here, 101.60 times 2,200. So that should be a positive number. So 207, sorry about that. Didn't need to put that second negative sign in there. So the upper bound, same approach, is going to be, let's see, the intercept plus the upper bound of the 95% confidence interval times 2,200 square feet. Let me just throw some dollars on that. Let's see, format cell, currency. We don't need any decimal places. I think that's good. So here's what we're saying at this point. Based on the regression results, we're saying we know that the 95% confidence interval on price per square foot is somewhere between $101, $115. So when we extrapolate that to a house that's 2,200 square feet, we're saying that the 95% confidence interval, the lower bound, it's about 207,000, upper bound's about 237,000. And notice that your estimate of 222,000 fits in here very nicely. So that's exactly what we would expect as you go through this drill using the regression results to find the estimate, just kind of the straight up estimate based on all the data and the average price per square foot. And then when we look at the upper lower bounds of a 95% confidence interval, you know, we get an upper and lower bound on the price per square foot, and then you can go ahead and make your estimate. And notice again that the 222 fits in there pretty nicely. So I hope this helps. If not, give me a shout back. Thanks.